Well, we mentioned that atoms of different elements are different from each other. And the way that they are different, that's most important, is the number of protons. So all atoms of an element have the same number of protons. Remember, Dalton's theory said that all atoms of an element were exactly the same. Well, they're not exactly the same, but they all have the same number of protons. So the number of protons is a little bit like your personality. You can change your hair, you can change your clothes, right? You could even get a tattoo or, who knows what else you could do to yourself. But you are still you. You can't change who you are. You can change what you look like, but you can't change who you are. An atom cannot change who it is. The number of protons do not change. That's its identity, its personality. So the number of protons is very important, and it's called the atomic number. And on the periodic table, we see a lot of boxes, little squares like this, with the element symbols and a whole number usually above it. That whole number is the atomic number. So this is the square from the periodic table for gold. Gold is AU. Because that's what you say when someone runs off with your gold watch. You say, "Hey, you, come back with my watch." Yeah. So how many protons does a gold atom have? 79. So we have the big periodic table on the wall. We can look at any of the elements and see how many protons the atoms of that given element have in their nucleus. We have a notation that helps us to describe these guys. Each element, like I said, has a characteristic number of protons. That's the atomic number. For some reason unknown to me, that is given the symbol Z. Z is the number of protons. The total number of protons and neutrons in the nucleus is called the mass number, and that's given the symbol A. Wouldn't it make more sense to make A the atomic number? Am I crazy? That should be. Anyway, they didn't ask me. The mass number. Okay, the two particles that have mass are the protons and the neutrons. The electrons are too tiny to even consider. So the mass number is the number of particles that have mass, the number of protons plus neutrons. And so this is an example of the atomic notation that we use to indicate how many protons and neutrons. So SY is standing for the chemical symbol for the element, could be one or two letters. And then off to the left, there's a superscript and a subscript. And A goes on the top, that's the mass number, that's the protons and neutrons. And the atomic number, the number of protons, goes on the bottom. So if we look at this symbol, this is an atomic notation symbol. Which element does this represent? Silicon. I'm waiting for my iPad to agree to let me draw on it. So this is silicon. What is the atomic number of silicon? It's 14. That's this guy on the bottom, 14. And you can kind of double check by looking at the periodic table. So what's the mass number? 29. The number up here is the mass number. So the atomic number is equal to the number of protons, right? So that equals the number of protons. And the mass number is the number of protons plus the number of neutrons. So how do we figure out the number of neutrons? We subtract. This is what I think is cool. If you just look, it's all stacked up for you to subtract. So 9 minus 4 is 5, and 2 minus 1 is 1, and so there's 15 neutrons in this particular atom of silicon. So we need to understand what this atomic notation means. Isotopes. Isotopes are atoms of the same element, but they have a different number of neutrons. And so they've got the same atomic number, same number of protons. They are the same element, but one of them has a little more neutrons than the other. So their mass number is slightly different. Most elements have multiple isotopes, but there's nothing predictable about it from the periodic table. Hydrogen has 3 isotopes, and they even have names. This is protium and deuterium and tritium, and this one's radioactive. But these are their symbols. So all of them, do you see, have atomic number 1, because all hydrogen atoms have 1 proton. They differ in their mass number. This one has 0 neutrons, because if we subtract, 0 neutrons. And this one has 1 neutron. And this guy has how many neutrons? 2 neutrons. So that's how they're different. We often refer to isotopes instead of using that symbolism of the atomic notation, which is a royal pain on a computer. You have to go into the map editor to do that stacked superscript, subscript thing on the left. It's a pain. So a more common way to refer to these is by the element name followed by the mass number. So cobalt 60. So what would be the atomic notation for cobalt 60? The symbol is, go to the pen first. Cobalt, C-O, lowercase o. What does the 60 tell us? That's the mass number. Does that go on the superscript or the subscript? Super. So that's 60. What's the atomic number for cobalt? 27? Yeah. I don't know why. I couldn't see it. It was in stealth mode or something. So that's another way of representing that. And we can also sometimes just do the element symbol with the mass number after it. So CO 60. Carbon 14 is a carbon isotope that has a mass number of 14. How many neutrons does carbon 14 have? That's its atomic symbol. 14 minus 6 is 8, so it's got 8 neutrons. So what about an atom of lead-206? How many protons does lead-206 have? You have to look at the periodic table. You have to find the atomic number. Lead is Pb, and the number in the square with it is 82. So it's got 82 protons. That's off the periodic table. All lead atoms have 82 protons. That's what makes them lead. This particular one has a mass number of 206. So we need to take 206 and subtract 82, because 206 is the protons and neutrons together. It gives us 124. So it's got 124 neutrons. I'm going to let you try those on your own. Which two of these are the same element? The first and the last, because they, oh, good grief, they have the same number of protons. What element is that? It's sulfur. Yeah, sulfur is 16. So this, the number of protons, the atomic number, gives us the identity.